Hello, my name is Andrew Anderson, and I will be giving the overview on our group project for a rhythm game score tracker. The score tracker is designed to allow players to access various parts of their scores, including play data, arcade locations, and reports on their cost of playing. Um, as you can see here, we also have the attributes for each individual score, tracking things like song title, artist name, level rating points, and difficulty name. But the score tracker overall will also allow businesses to get value from this same data by analyzing things like most played songs, cost versus number of plays, new players over time, difficulty of songs versus scores, and much more. Additional attributes and functions are planned to be developed to help improve the user experience and to generate value for the users. It's worth noting that we normalized and simplified some of the scripts for generating the database. Our schema here illustrates how all of our tables are interconnected, such as how players are tied into their scores and account information, and how arcade locations are tied to payment reports. And we did also solve the many to many relation between players and arcade locations by having a bridge table for player locations. We will now be talking about how the database is created and some of the current functions and CRUD operations.
Hello, my name is Jacob Lopez and I'll be presenting AJJJ's Data Solutions Database. This is of course for our rhythm game score tracker, and what we do first is we create the database AJJJ database. If it already does not exist, we go ahead and use that database. And if these tables already exist, then we drop them, but since they don't, we create the payment reports, scores, player locations, arcade locations, players, and account information tables. So each structure for the creation of the tables goes as follows. We create the table with the name, and then for each attribute, we list them out. And of course, there's any important information like, the primary key, the text, of course, the types, we put that out. So we have an auto increment for the primary key for the account number. And then we do an insertion into the table with the respective values, of course. So for the account number, email, phone number, password, and payment information, for example. If there's anything different that we need to go ahead and reference, so for, in this instance, the account number for the players table, we have the primary key player ID, but then we have the account number that references the account information table we just talked about previously. So we create a foreign key constraint that references the account information table with account number. And so we do this for the other tables as well, such as arcade locations, payment reports, scores, and player locations. And as you can see here on my local machine workbench, we have each table that's created. And of course, the rest of this demo will go ahead and talk about everything else, such as our stored procedures and triggers. But as you can see, the insertions and the creation of the tables worked, as you can see here.
My name is Judith Infante, and I'm going to be going over the queries. And for this first query, it creates a new user account that has specific information on the user. The second query shows every row in the account information table. It's used to confirm that our inserts worked and that we can view them. And for the third query, it combines the player's table with account information. It shows each player's ID, username, region, and matching email address. Then for the fourth query, it updates one specific player, player 501, and changes the region to US. And simulates a user updating their location or profile settings. And the fifth query shows all players in the system. After the update, we can use this to check that the region for player 501 actually changed. And for the sixth query, it groups all the scores by difficulty, easy, medium, hard, expert, then sorts from highest average score to lowest. Okay, and then the seventh query, it joins the four tables, player scores, player locations, arcade locations, and shows who played, what song they played, their score, which arcade and city they were in. And for the eighth query, it combines players with payment reports, and for each player, it calculates how many times they paid to play and how much money they spent in total. Then it orders them by who spent the most. And for the ninth query, this removes one score record with score ID 3004.
My name is Jacob Garza. I'm going to be going over the procedure and trigger functions in the ajjj.sql file. For the procedure, we will first be taking an input value called inPlayerID, and then it will be returning each value, score ID, song title, difficulty name, and points for each player, going highest to lowest. Then we have the trigger. We will first be dropping it to prevent any rerun errors. And then before, the first thing it does when it runs, it will insert a row into payment reports and will check each row for a non-negative value. If there is a negative value, it will be sending an error message. We are also thinking on putting in a SQL injection prevention feature to further add a robust security system.